Okay, we're going to be looking at this more complicated trig equation here. 4 sine 4x is equal to 3. The first thing that you really need to do in this case is to rewrite the equation as sine 4x is equal to 3/4. Okay, so divide both sides by 4. Now, first off, think about what has happened to the sine curve. The transformation is a stretch. It is in the x direction and is by a factor of 1/4. Now, normally sine x has a period of 360 degrees. So if the sine curve has been squashed inwards, okay, so imagine your sine curve, okay, it has been squashed inwards, the period is now 1/4 of the length. So the period is now 90 degrees. Okay, that's important. Now, between 0 and 360, we would have expected there to be 2 solutions, but because it's been squashed or been stretched by a factor of 1/4, we would now expect there to be 4 times as many solutions. Okay? So, in actual fact, we're looking for 8 solutions. Okay, so that's a lot of solutions to look for within that range of 0 to 360. Now, first off, ignore the 4x. Let's just have a look at sine x is equal to 3/4. Okay? So, if I'm going to solve this, I draw out my sine curve. Okay? 1 minus 1, there's 360, there's 180. Okay. Now 3/4 round about here. Okay, so we can see the 2 solutions, one here and one here. The first solution can be got just from putting it straight into your calculator, inverse sine of 3/4, and that is equal to 48.59, etc, etc. Okay, so I'll write 48.59 to 2 decimal places. Okay, and the other solution will be 180 degrees take away 48.59. Okay, so that is 131.41. Now, these are not 2 of my final solutions. They are solutions to sine x is equal to 3/4, not sine 4x is equal to 3/4. Okay, so what we need to do is we really need to say, well, put it on pen. Okay, what we need to say is that now, okay, well, if x was the 48.59, then 4x must now be that 48.59. So x, my first solution, will be divide both sides by 4. Okay, and I get 12.1, about 12.1 degrees. If I have a look at the other solution, so 4x is now 131.41, then x2, my second solution, will be 32.9. Okay, now they are both between 0 and 360, so that's fine. Okay, they are 2 of the solutions out of the 8. Now, if we return to this idea that we had that we've got 8 solutions and the period is now 90 degrees. What I can now do is I can add on 90 degrees or take away 90 degrees and get the other solutions. Now, if I take 90 degrees from either of these, I will be outside of the region. I'll be outside of the 0 to 360 region because I'll go into negatives. Okay, so what I'm going to do instead is I'm going to go, okay, well, x3, my third solution, I can look at 12.1 plus 90, okay, which is 102.1. So there is another solution. I can then look at 32.9 plus 90, okay, and that's 122.9. So there are 4 solutions out of the 8. Fifth solution, okay, well, I'll take the 102.1 and I'll add another 90. That's 192.1. Okay, that's my fifth solution. Now I'm going to take that 122.9 and add another 90. Okay, and that's going to get me 212.9. That's my sixth solution. Solution 7 will be 192.1 plus 90, which is 282.1 degrees. And the final solution, x8, is 212.9 plus another 90, which is 302.9. Okay? So that gets me my 8 solutions. So I'm adding on the period of the graph of sine of 4x, which was 90 degrees. Okay? It's very important. Okay, so there's a lot of steps in this, a lot of things to think about, okay, but if you work through and build up a process with other examples, then you should start to be able to see where things are coming from.